Hello, my name is Thales Senkorting, and in this video I will show basic change detection in remote sensing. We have these two images from two different moments. These images are the panchromatic bands from the Sibers 4 satellite. The first image was acquired in 2015, July 12, and the second image in September 24th, and the year was 2018. We have to assume that both images are co-registered. The main idea is to call the first image the image at T1 and the second the image at T2. We will use basic image processing operations to highlight the main differences between the two images. According to the literature, ideally, resolutions are constant, and we mean by temporal resolution, spatial resolution, spectral resolution, radiometric resolution, and also the look angle of both images. But we know that sometimes this is not the reality. However, we assume that the resolutions are constant to make the computations we are going to show. If we show the histograms of the two images at T1 and image at T2, we have this difference here. The blue line is from the image at T1 and the orange line is the histogram at T2. We can perceive the differences between these two histograms, and we're going to use a basic arithmetic operation to deal with these differences in histograms and also to highlight the natural difference in terms of land cover change. I propose here a very simple index which I will call NDTS. Is completely based on the well-known NDVI index, and here we will call normalized difference of time series. The equation is the image at time 2 minus the image at time 1 divided by the sum of both images. When we divide by their sum, we normalize the result and we try to compensate possible differences between the two images and to highlight only the land cover changes. When we apply the NDTS in the two images, we can get this result here, which is not so easy to highlight the differences. When we see the histogram of this image that highlights the differences between the two images, we can think about where are the changes represented in this histogram. Small values and also the higher values of the histogram point to possible land cover changes in this time series. To highlight easily the differences, we can square this image. So if we provide this squared normalized difference of time series, we will see that the negative values will not appear anymore and all the values will be greater than 0. So we have all this limit here, and now define where is the point in which we consider to be change or to be not a land cover change. So if you assume a threshold of 0.1, for example, and apply this threshold to this image, we can get a map like this one, a normalized difference of time series squared and also higher than the threshold of 0.1. The black pixels here are points which means no change, and the white points are points which means change in the land cover. They were highlighted by the threshold. We understand that several of these isolated pixels here are probably not a change detection, but can be the result of possible noise. If we apply a very basic image processing technique like mode filtering, we can get this result here, kind of a clean up of the image. All the white points here should be translated into change detection between the two images. I used this reference, Introductory Digital Image Processing by Jensen, to get some of the points that I showed in the beginning of the video. All the material, including the images used, the LaTeX equations, and also the algorithms written in Python, are available in my GitHub.